All right, so we are looking at end behavior. And so what this means is when we plug in really, really large numbers of x. So when x goes out to infinity, what is happening with our y values? So there's a couple of rules here that you can memorize and easily be able to figure these things out. So let's start with even degrees of your leading term. So in A, we're talking about x to the fourth. That's your largest degree, it's your leading term, and it's even. So if you have an even degree for your leading term, then your function is going to be doing something like this as x goes out to negative infinity. So let's put some axes on here. And also going up to positive infinity when x goes out to infinity. So you kind of get this parabola shape. When x goes out to infinity, your y is getting very large, going positive infinity. And when x goes to negative infinity, your y gets very large, going up to infinity as well. So what we have for end behavior on A, so this is for A, we have this general shape where it's going up to positive infinity and positive infinity. So you can kind of think about x squared. X squared looks like that u, looks like that parabola. So if it's an even degree and it's positive, then it looks like this. So you could represent it on an answer like something like this. You could say y goes up to infinity from the left and the right, however you would like to describe it. Your textbook will use this. So that's for a positive even degree. Now take a look at letter C. We have a negative x to the sixth as our leading term. So think about negative x squared. What would happen with negative x squared? Well, it would be still that same U shape, but it's going to be flipped upside down. So as x goes to infinity, your y goes to negative infinity. And when x goes to negative infinity, your y goes to negative infinity. And so to describe this, you can draw this. You could describe it going to negative infinity for your y's. However you would like to do it, again, your textbook will give you the picture. And notice how we're leaving the middle space blank. So we're not connecting these arrows right here. And that is because all I'm figuring out is what happens when x gets really, really large. So when x goes to infinity, or when x goes to negative infinity. So I don't care about what's happening in the middle. I'm just figuring out that end behavior. And we can just take that leading term, that negative x to the sixth, when x goes to infinity, because that's going to take over. So if I'm plugging in like x equals 1,000,000, x squared minus 4 is not going to do anything to my function. That negative x to the sixth will take over. And so that's the general idea of looking to your infinities and negative infinities. So those are for your even degrees. Now let's take a look at B. At B, our leading term is 3x cubed. So we have an odd degree, and it's positive. So odd degree and positive, think about x cubed, which we actually kind of have as a leading term. We have 3x cubed. So if you think about x cubed, we have this general shape. So what happens with a leading term with an odd degree, and it's positive, it's going to follow that pattern. So it's going to, when x goes to infinity, your y is going to go to infinity. And when x goes to negative infinity, your y goes to negative infinity. And so we get this general shape. And again, your textbook will give you that picture description rather than using sentences. So that's for a positive odd degree leading term. Now, if you look at letter D, we have a negative x to the 7th plus x minus 4. So here, again, think about negative x cubed. Well, negative x cubed is just going to be the flipped version. So it's going to go up to infinity when x goes to negative infinity, and it's going to go down to negative infinity when x goes to infinity. So we have this general idea. When you have a negative leading term with an odd degree. So really, if we can remember our quadratic looking like a u and our x cubed function looking like letter b, then we have all of our end behaviors. Because we just need to remember that negative is going to reflect it over the x-axis. So even degree, you're going in the same direction. Odd degree, you're going in opposite directions. And remember, it doesn't matter about the other terms. So in A, x to the 4th minus x squared plus 5x minus 4, it doesn't matter about the negative x squared plus 5x minus 4, because when you're plugging in really, really large numbers of x, those are going to get overshadowed by that x to the 4th term. X to the 4th is just going to take over and control your function. So all you need to do is look at that first term and make sure it's going in descending order of degree. So you may need to rewrite it.